Yeah, can you guys see what I'm projecting right now?
Yes.
Okay, this is multivariate control chart. I'm actually going to introduce you to a multivariate control chart today. Um, Today is July 6th, but I uploaded this material, I prepared this material as at July 2nd, okay? But this is basically what we're supposed to do today, okay? Now, multivariate control chart. Has any of you heard about control chart before? Has anyone heard about control chart before? Is there anyone who have heard about control chart before?
No.
Okay, let me first tell you what the meaning of control chart. You know, every company that is into production, okay, uh, they have what we call uh, internal control unit, and in the internal control unit, the unit will ensure that whatever that is produced, conform to specify standard. Okay, so every production companies actually have control unit. Okay, if you look at it, there's some companies that are into medical assembly where they assemble medical products. Okay, they have a way to check whether what they've produced uh, they measure up to standard. Okay, let me first tell you, what do we mean by quality? Okay, what do we actually mean by quality? Okay, by quality, quality is a measurable characteristics of a product, a service. Okay, because it may not necessarily be a product. What about service? The service render. As I'm teaching you right now, okay, there should be a way to measure whether this whether my teaching delivery measure up to standard. Okay, so when we talk about we have a way in statistics to be able to measure this, whether a particular process or a particular whether a production process or whatever is within control or not. Okay, and that is the reason why, of course, you are aware of the regulatory body, the regulatory bodies for quality of education, for food, drug, and whatever, and so on like that. And there's another body called consumer protection, where they're going to make sure that whatever you get from grocery store, whatever you buy, commensurate, you know, to the value of the money that you pay. Okay, so uh, statistical way to be able to measure whether certain variable of interest measure up to standard. Okay, and that is what we call control chart. We use control chart because we'll be able to see whether a particular process is within the control or is out of control. Okay, and that's exactly what we're trying to do right here. And you know what? If we're considering one variable, okay, if we're considering one variable, okay, if we're producing one item and we want to make sure that whether it is want to investigate whether it is within control or it is out of control, we're going to have a way to measure that. Uh, for those of you who have worked in a factory before, of course, every factory has an internal control unit, okay, where they're going to take a sample of what they have produced and they're actually going to test that for quality, okay. And in the process of testing that for quality, of course, there is possibility that they could actually observe a particular item that is out of control. Okay, and if it is out of control, and they have a way to correct for that. Okay, so you but in a situation where you have more than one variable, where you want to say, okay, maybe you're in the company, you are producing more than one item, and you want to test whether this is out of whether this is out of control, this is out of control, and stuff like that. If you have more than one variable, then we're going to be talking about multivariate control chart. Okay, so what I want to walk you through right now is to start with the univariate control chart, because you need, for you to be able to understand the multivariate control chart, you need to understand the univariate control chart. Okay, are you guys hearing me?
Yes.
Okay, so for univariate control chart for a mean, we need to observe n values, okay, of x at each n time point. Okay, then we're going to obtain the mean and the standard deviation. Okay, of course, we're going to have several means, several standard deviation, because it's just like we've been working, and okay, we collect a sample of our product, probably from within month of January. We find the mean for that. We do the same within the month of February. We find the mean for that. Okay, so, and that is why you have several means. Okay, and when you have several means, you're actually going to have several standard deviation. Okay, because we are observing n values of x at each n time point. Of course, this is the formula you can use to find the mean, and this is a formula to find the standard deviation. Okay, now in step 3, you need to find the mean of the means. If you look at this, maybe this is the mean of the item that you produce in January, maybe the mean in February, the mean in March, and so on like that. If you now add all the means together and you divide by the number, okay, and that is why the number that I'm using here is different from the one I'm using right here. The n here actually represents the number of means that we got. Okay, so, and that is why you see bar bar, that is the mean of the mean. Okay, and we're also going to have the standard deviation of the standard deviation. Look at that. If you look at this guy here, the variance of each period, the variance of each of that we have obtained. Okay, we're going to put it right here. We're going to be summing that. Then we're going to find the square root of that, and this is going to be the general standard deviation. Okay, I'm going to say that again. This is the overall mean that I call the mean of the mean, and this is the overall standard deviation. Okay, now what am I trying to do? I'm actually investigating, whether maybe whether what we're producing is out of control or not, by trying to find the mean and the standard deviation. I started by saying, okay, we collected data set of what we produce. Since we produce every day, okay, okay, we find the mean of what we produce for a particular month. We find the mean for the second month, and so on like that. And at the same time, we're going to find this variance of each of that. Okay, and right here we find the overall mean and overall standard deviation. The overall mean is actually going to be the mean of the mean, and this is how to figure out the overall standard deviation. The next thing that we're going to do, we're actually going to construct a chart where we need the UCL here. Okay, the UCL is called upper control limit. The upper control limit is going to be x bar bar, which is the overall mean, plus 3, then the overall standard deviation divided by the square root of n. Okay, then in the lower specification limit, I'm actually going to be subtracting that from the overall overall mean. Okay, then I'm actually going to have a center line. The center line is this. Okay, the center line is this. Okay, Now, I'm actually going to plot now. In my plotting, I'm actually going to indicate the center line, the lower control limit, and the upper control limit. Okay? If everything is perfect, if everything is perfect on the center line, I expect everything that I produce to be on the center line. But that is not going to be possible. Okay? Even because our machines are not perfect, we actually expect to have a deviation, okay, the deviation from the center line. But you know what, this the deviation from the center line should not be, should be within 3 sigma. As any one of you heard about a company in the state of Minnesota that is called 3M? Has anybody heard about that? 3M?
Yes.
Yes.
This is what they do. And that is why they call themselves 3M. Because they know that they are into production. And you know what? There's going to be deviation in life. But the deviation should, the one that can be tolerated, it should be the one that is within 3 sigma. Okay, it should be the one that is within 3 sigma. So this is the 3 they're talking about. Within 3 sigma, the sigma here is x divided by root m. So the 3 sigma within 3 sigma is okay, plus 3 sigma or minus 3 sigma. Okay, so like I said, I'm actually going to use that. And you know what? Any point that is outside the lower control limit and the upper control limit are considered to be out of control. Okay, any point that is outside the lower control limit and the upper control limit are considered to be out of control. Okay, if you find yourself in a company where they are into quality, where they measure quality, this is actually what you're going to do for them if you really want to assess if the situation for quality. Okay, so any point that is outside the lower control limit, of course, you know how to figure out the lower control limit, you know how to figure out the upper control limit. Any point that is outside that is going to refer to as an out of control, and that is not good at all. Okay, and that is what the internal control unit, that's exactly what they do. Okay, now in a situation whereby if we have unequal sample sizes, okay, you know, assumption here is that the sample size that we're using to arrive at each mean are the same. Okay, we can have a situation where we don't work with equal sample sizes. Of course, the formula is actually going to change. Okay, the formula is actually going to change, and the formula is actually going to change to this. Okay, the formula is actually going to change to this. Okay, and this is what you're going to use for the upper control limit, and this is what you're going to use to find the lower control limit. Okay, and like I said, any point that is outside the lower control limit and the upper control limit will be regarded as an out of control. Okay, now we want to have an example right now. I want us to have an example right now, and I'm actually going to be using the National Football League. Okay, this is not football in Africa or in Europe or in Asia. This is American football. What I'm talking about here is American football. Okay, now the National Football League, the data of the National Football League of 2018, where we actually want to consider the NFL home team point spread deviation by week. Okay, and the data set we actually want to use is a point spread for home team, of course, which is actually going to be negative, means home team favored. Okay, and the point differential for home team, so which is the home point minus the visitor point. Okay, that is termed as HD. Then the spread differential, which is the HD plus PS, comma, the positive means home team cover the period. Now, take a look at what I have here right now. This is from week 1 to week 17. Can you see that now? Okay. And in week 1, we got 16 to be the number that we consider, and we compute the mean. Can you see now? This is the mean based on this 16 observation. This is the mean based on this 16 observation, and so on like that. Of course, you know, in every week they play more than 16 games. I mean, they play more than one game. Okay, they play more than one game. Okay, I think you know that. Okay, so this is like the average from that. Okay, and this is the standard deviation that we compute from that. Okay, now when we have this information right now, how can we compute the mean of the mean? Okay, if you want to compute the mean of the mean, and this is what you're going to do, you're going to do 16, the 16 right here, multiply by this guy, okay, plus the L, okay, plus 16, okay, into minus 5.188. I'm going to show you why you have that one. I'm going to tell you now. The minus 5.188, you know, you're like distance this, you're now adding it up. You're adding it up until you get what? 16 times that, okay? So what I'm trying to say is that this is a last number, okay? So what I have here is just this guy times this guy, this guy times this guy, this times this, until you get to this times this. Then you're going to add up, then you divide by the addition of all this, okay? That's exactly what we're doing here, and that is what gives us this, okay? Is there anyone who want to ask question about that, how to get the X bar? Is there anyone? Okay. I think you guys are hearing me, right?
Yes.
Okay. So, like I said, you're going to use this guy to multiply the X bar, this multiply by that, this multiply by that, until you get to the last one. Okay, then you divide everything by the addition of this guy here. Okay, and that's going to give you the center line. Okay, because if you want to draw a control chart, you actually need a center line. Okay, so we want to look at the deviation from the center line. Okay, now after that, you need to get the combined standard deviation. Okay, if you want to get the combined standard deviation, you're going to square this guy here. Okay, it's this guy here, multiply by 16 minus 1. Okay, plus you're going to square this guy here, multiply by 16, until you get to, you're going to square this guy, multiply by 16 minus 1. That's exactly what we're doing right here. They're divided by 16 minus 1 plus 16 minus 1 until you get to the last 16 minus 1. Whatever you get, you find the square root. What I have here is overall standard deviation. Okay, now that I got my center line, then I can compute my lower control limit. Okay, and I can compute my upper control limit. Okay, if I want to compute my lower control limit, okay, what I'm actually going to do, okay, I'm actually going to use the X bar right here. I'm going to put it here minus 3 times this. What is X? This is my X, 12.797. I'm going to put that here. Then divided by MI. Of course, you're going to, for this guy is going to be, how many of that? How many of this are you going to compute? 17 of that. Okay, 17 of that. Because you're going to use the first one, you're going to use for 16 and so on like that. So you're going to do the same thing to this. Okay, but let me tell you this. In a situation where the center line, look at the center line right here. The center line is negative, right? When the center line is negative, then you have to set that to be as 0. And that was why I said here the target mean is 0. Okay, the target mean is 0, so that a center line and HCl is going to be this. Of course, anytime you have a negative, okay, the center line is going to be 0. When I plug in 0 here, of course, I'm actually going to have that. I think you know that, right? But when you don't have 0, you have to use the value. But when you have a negative, of course, you have to put 0. Okay? Now, and you know what? The moment you get that, I actually want to show you there's something now. Look at that. I want to show you now. Now, when you take a look at what I have right here, this is the center line, right? This is the upper control limit. Okay, this is the chart. You plotted, you know what we plotted, right? Okay, we plotted the lower control limit and the upper control limit against the sample size. Okay, again the different. Can you see that? That for 17. Okay, week 17. Okay, for 17 weeks. Okay, now these are the points. Okay, now do we have a point that is outside the upper control limit or that is outside the lower control limit? Do we have any point? Is there any point?
No.
No. Okay. So it means the spread differential process varies. We know it varies, but it never become out of control. This is good. Okay. So in every company where they are into production, they have to ensure quality. How can they ensure quality? When they are done with the production process, they actually need to investigate for quality by using the quality control chart. Okay, now I've used that for the NFL now to see whether things are out of control or not. Okay, I think you can see that now. Okay, so what I just used right now is the univariate chart, univariate control chart based on the mean. Okay, but we also have the univariate control chart based on the standard deviation, which is what I'm showing you right now. But you know what? I'm actually going to continue from here tomorrow. Before I start the lecture for tomorrow, I'm actually going to continue from where we stop. So this is where I'm going to start from tomorrow. Univariate control chart for a standard deviation. But you can read that up, okay? You can read that up. Look at that. We also apply that again to the NFL data, okay? Because the one we applied before was a univariate control chart based on the mean, okay? This is a univariate control chart. Look at that, based on the mean. Although when you are basing things on mean, that doesn't mean you are still not going to use standard deviation. We still use standard deviation, but this is typically on the mean because the center line was the mean, okay? But we can see I have another control chart, okay, that is actually going to base on the standard deviation, and that is where I'm going to start tomorrow. Okay, you can read up. So this is the one that is based on the standard deviation, and you can see the one that is based on the standard deviation, the center line is going to be the mean of the standard deviation. Okay, and that is going to be the difference. So I'm going to explain this tomorrow. Okay, and after that, you look at the application, you see the decision whether you're going to take the same decision with that of the mean. You can read up. Then from there, we're actually going to extend that to multivariate, a situation whereby we are looking at more than one variable at a time, okay, where we are seeking quality. We are seeking quality in more than one variable at a time. We're investigating for quality, okay? I'm actually going to show you the multivariate part as well, okay? But you know what? I need you to understand the univariate very well before you can understand the multivariate, okay? So is there anyone who want to ask question today before I go? Is there anyone? Is there anyone want to ask question?
Professor,
Okay, go
are we,
ahead.
are we going to finish the last slide of the comparisons among treatments or groups?
You mean the last slide? Oh,
Yes.
oh, you the one for the multivariate?
Yeah, we were talking about it at the first half of today's lecture.
Yeah. What is going to happen? I'm actually going to watch my video, and if I've not finished that, of course, we still have a lot of. I'm still going to revisit that. Does that make sense to you now?
Yes.
Okay.
Thank you.
Okay. So this is going to be the end of my lecture today. I hope you guys enjoying it. We're going to continue from this tomorrow. Make sure you stay safe and do have a good day.
Thank you.
Thank
You're
you.
welcome. You're welcome.